Hi, in this lesson I will talk about network in graph theory part 2. This is the subtopics. Have a look on the first subtopics, directed and directed graph. Okay, we compare these two types of graph in the context of simple graph. So I want you to pay attention into this edge. Okay, for undirected graph by itself, means undirected, no directions. And by the word directions is with directions. And how do we know? Because of the symbol. So with directions, directed and undirected graph. For the edge AB, this one, you can call this edge either by label it as AB or BA. Okay, AB will be equal to BA, but for directed graph in this case, you can only regard this as a BA. Okay, you can only call it as BA, but not AB. Okay, BA will not be the same as AB. In this case, order is important because when you look at the arrow, is B to A, from B to A, so you go for BA, but not AB. So this is the first thing you have to remember, the order and the name of the edge. Okay, one more thing, if you pay attention into the vertex C, now I'll talk about degree of vertex. So you pay attention to vertex C. For undirected graph, you will say that the degree for vertex C would be 1, 2, 3. 3 edges connected to it, so degree is 3. In this case, because with directions, it has to be more precise. D in vertex C, D out vertex C. In and out, I think by the word itself you understand. Okay, look at this. These two arrows going into C, so 2. This arrow going out from C, this is 1, so 2, 1, in 2, out 1. The degree for vertex C, that will be 2 plus 1, 3. Still 3, but it can be more precise. In 2, out 1. Okay, we have a look on these two in groups and multiple edges. Few things I want you to pay attention. For example, the multiple edges. The multiple edges in this case, you can either call it as QR, QR or RQ, RQ, up to you, without directions. But in this case, you can only call this as QR and this as RQ. That's it. Okay, QR, RQ with directions. What else do you need to know? This one, I want you to pay attention to vertex T. Okay, this is the directed graph, so you know that that will be D in for T, that will be T out for T, and the degree for T. Okay, how many in, how many outs? For a loop, you know that it is going out from T and going in from T, going into T. So in is 1 in, yeah, there's only 1. Out, 1 out, 2 out, 3 out. So 1 in, 3 out. Degree for vertex T is 4. Okay, can be very specific. And then sometimes you will need to draw a directed graph based on information. Our information could be give you the vertices and also give you the edges. So you need to draw lah. My advice is you can always start with a square, usually lah, but not all the time. You can start with P, the first vertex, PQ. So you draw PQ, P to Q. What else? PR, PQR, PR, PQ, PR, alright. RQ, shouldn't be any problem, right? Looking at this RQ and then SR, PQRS. So SR, PQSR, SQ, PSQ. You can draw like this, even though it's intercept, no problems. Okay, no problem with interceptions. PQRS and then ST. Where's your T? Maybe here. ST. Okay, are we done? Is this the complete directed graph with informations? The answer is No. No. Why? Because you see, vertex U, how? Vertex U is not connected with any of the other vertices, but you have to list out. You have to list out vertex U. Okay, so this is the ones. Okay, now B, there's a loops. This is a bit hard. You have a loop, you have a multiple edges, and they give you the degree of vertex in and out. This is a bit hard. I would advise you all to take a piece of paper or any recycled paper and try first. Try not to use pen, use pencil so that you can correct and rub it off. Okay, usually I will do like this P, Q, R, S. So there's only 4 vertices. P, Q, R, S. Okay, I look at this one. Look at vertex Q. I start with information that is very specific. So look at vertex Q. Okay, what else? Multiple edges at RS. So maybe I use different color. Okay, we must give direction, you know. But how do we know? We have to check. You have to check out RS. RS, do you see a 0 here? 0 meaning R 0 is in for R is 0, you know. Meaning everything here should be going out from R because 0 going into R. So it should be going out from R. Going out from R. So going out from R just now 2 already. So now you have 1 left. So you have to try this one, really no choice. So maybe RQ, R to Q, so here no more. And then Q, we look at Q. Q, in 1, out 1. In 1 or in 2 already. So in 1, out is 1 left. PQ, P is in, out. P to Q, maybe P to S, I don't know, I'll just try. 1 in, 1 out. 1 in to Q, 1 out from S. So Q settled already or not? Q is, let's see, 2 in, 3 in already. Q is 3 in already. So 3 is settled. We check and see. Q 3 in already. Oh my god. Okay, 3 ins, 2 outs. Okay, 3 in, 2 outs. For R, settle. For S, settle. 1 in, 1 out. For S, 3 in, 1 out. Oh, just nice. Okay, so this is the answer. You just have to try, no choice. Okay. This is the model answer for you. Okay, and also we talk about weighted and unweighted graph. It could be directed, it could be undirected for weighted. It could be directed, it could be undirected for unweighted. So same thing, no difference. The difference is for weighted graph, you have a value. Unweighted graph, no value. Okay. For example, these ones. You look at this diagram. Weighted or unweighted graph. This is the value lah. So this is a weighted graph. Okay, I ask you extra question. Directed or undirected questions? Obviously, this is a directed questions. Okay, we go with this one. The diagram right show a one-way path Izaru can choose for running practice. Vertex 1 is starts, vertex 5 is end before go home. The shortest distance 1 to 5. The shortest distance 1 to 5. I believe this is very easy lah. Shortest distance 1 to 5. 1, 2, 2, 5. Right. 1.1 km. Longest distance. Longest distance start from 1. Yep. 1, 2, 2, 3, 3, 4, 4, 5. Is it 1.5, 2.0, 2.5? Yes, this is the longest distance. Okay. The vertices, you need to find the vertices, there must be pass through. If the distance to overrun between 1.4 and 2.1, you just have to check 1.4 and 2.1 between that. How do you run? Start from V1 and with V5. It cannot be the shortest, cannot be the longest. Why? Because it's between 1.4 and 2.1. So maybe 1 to 2. 2 to 4, 4 to 5. 1.4, 1.9. Yes, this is between. So you have V1, V2, V4, and also V5. How many? 1.9 km. Okay. Is this the only answer? We check and see. 1, 2, 4, 5. Where else we can travel? Huh? Let's try. 1, 3. 1, 3 can or not? 1, 3. 1, 3. 2.4, 2.2, or 2.9, more than that, I think. Maybe this one? 1.5. Hey, this one can. Yes. So 1 V1, V3, V4, V5, 1.5 km. Okay. Is there any more pair? Let me check. Yep, no more. I think. Right, and this is the possible answer lah. The vertices must be passed through 1, 2, 4, 5, or either 1, 3, 4, 5. Okay. Thank you.